Hello everyone and welcome to day 2 of integration. We're going to look at something called integration by U-sub, and it's the opposite of chain rule. And so nothing really that different about it except for the fact that you're doing integrating, this is dealing with integration. So the idea is you choose an appropriate value of U, just as the chain rule, you're looking at parentheses, largest exponent, or the complicated part. I'm going to find du. Express all the parts of the integrand in terms of u, take the integral, and then put back in terms of x. So if we look at this first one, and I'll try to go through it slowly with you, this is our u. So we have u equals x squared plus 1. Now, with implicit differentiation, since we've done related rates, you should understand that the idea that we're taking the integral with respect to x here. So when we take the derivative here, we're getting du over dx since we're taking the integral with respect to x. So du dx equals 2x. Now, we took the derivative with respect to x, so we don't need anything at the end of this, but we don't want dx on the du side. So we're going to cross multiply, get it over. And so what you have now and how it should work out for the simpler ones is that du equals 2x dx. Look what we have up here, 2x and dx. That is our du. And so we just did step 1, we did step 2, and now we're doing step 3. And if I wanted to, I could go back here and say this is the integral of u to the 50th du. Because the 2x dx is right here, and that was du. Now, when it's all in terms of u, we're just going to take the integral. The integral of u to the 51 over 51 plus c. Great, that was easy. And now, to get it to be our final answer, we got to get back in terms of x. We're going to take what our u is. Our u is x plus 1, x squared plus 1, all raised to the 51 over 51 plus c. And there's our final answer. If we want to check this, 51, take the derivative of it, 51 comes out in front, the 51's cancel. You can get x squared plus 1 to the 50th times the derivative of the inside. What's the derivative of the inside? 2x, and that's where we get our 2x here. So 2x, x squared plus 1 to the 50th, would be what the derivative of the integral was, and so we did do it correctly. So let's look at this next one. Now, there's trig functions, I understand that. Let's look. The inside, we said, was usually in the parentheses is x plus 9, so we're going to let u equal x plus 9. Du equals 1, and then you would get over dx here. The shortcut way that we're going to do here, just so you know from now on, when we take the derivative of u, you can always write it as this, but the dx is always going to come over here by cross multiplying. So we're just going to we're going to end up writing it as just du equals something dx, making sure that we have variables of x here. So we get our 1 dx. So what did we just get? If this is the case, there's our dx, there's our dx. We could rewrite this as the integral of cosecant u, cotangent u, du. So you go back and look at your notes from last class, and you realize that cosecant u, cotangent u, the integral of that is negative cosecant u, and then plus c. And so our final answer is negative cosecant of x plus 9 plus c. To know this, you would go back and look at your notes from last class where we gave you the chart to understand that the integral of cosecant cotangent is negative cosecant. So, fairly quick notes today. I'm going to go through some of these with you and then let you try to get some on your own, and I'll go over the more difficult ones. So, the first one and the second one you guys should be able to do on your own, so please do that. So, if you were stuck, here's the 2 answers. One of the things that you will realize is that here, when you got u equals 5x, there wasn't a 5 dx here. And so therefore you had to divide by 5 to get du over 5 to equal dx. And then this du came here, and the 1/5, because you divided by 5, came out in front. And that replaced the dx. Sine u, and then so on. The same idea over here. U equaled 1/3 dx. You only wanted a 1 dx. So therefore, 3 du equaled dx. You bring the 3 out in front. Replace the du with the dx. You have u to the negative 5. You brought up the u to the negative 5. You have the integral of 3. Or you have the 3 integral of u to the negative 5. Add 1, divide. And you're left with the answer of negative 3 all over 4 times that to the 4th plus c. Okay, so to get to the little more difficult problems now, let's look at this one. If we take the inside of the square root and make that u, we're going to get 3 minus 5t to the 5th. And let's make it du. We're going to get negative 25t to the 4th, dt. And why do we like that? Well, we have a t to the 4th dt that we haven't taken care of, and we already have a t to the 4th dt here. So that's good. So we just got to get to that negative 25 over. So we're going to get negative du over negative 25 equals t to the 4th dt. And we'll rewrite all of this out with this negative 1/25 over to the side. Like that. The integral of u to the 1/2 du. And then all we're going to do is take the integral of that. Let's make sure though it's a cubed root, 1/3 there. So we're going to get u to the 4/3 all divided by 4/3. Remember, we multiply by the reciprocal here. Multiply by the reciprocal, so we're going to get negative 3 over 100 u. U is 3 minus 5t to the 4th, 3 minus 5t to the 5th. Wow, sorry about that. All raised to the 4/3 plus c. And that's it. This one, you guys split it up. And so we're going to get the integral of 1 over x plus the integral of secant squared pi x dx. You need the dx there. I'm forgetting these dx's this video, but you do need the dx's everywhere you do. Go. So let's see here. The derivative of 1 over x is the ln of the absolute value of x plus the u pi x du equals pi dx. Now notice here that we only need the dx. So we got to divide this pi over. So we're going to get 1 over pi, the integral of secant squared of u du. Now the absolute value of x plus 1 over pi. What's the integral of secant squared? Well, the derivative of tangent is secant squared, so we got tan of u, and what was u? Pi x plus c. And so the last two here that we're looking at are a little more complicated. I'm going to skip this one for now, and we're going to go look at this in class. But I do want to look at this one. E to the something. Well, our e to the something is the square root of x. So u is going to equal square root of x, which is also x to the 1/2. Du, bring down the 1, you guys all know this, should look like that. Dx. If you look at what we have left over, is that we have left over is 1 over the square root of x. That's what we haven't taken care of. We've taken care of e to the u, but we haven't taken care of this 1 over square root of x. Well, if we look here, what's nice is we have the 1 over square root of x. The only thing we don't have is the 2. So let's multiply this 2 over to the other side. And this now has just been taken care of with that. So we're going to rewrite this as 2. That's where the 2 is. Integral of e to the u du. That was taken care of with this. And this is now the integral of e to the u is e to the u plus c, and we plug in our u. 2 e to the square root of x plus c. Done. And we can't part without my corny joke of why did the bicycle fall over? Why did the bicycle fall over? The answer, because it was too TWO tired. So we'll finish this one up in class, and I will see you guys later.